Good morning, students. Am I audible? Am I audible, students?
Yes, ma'am.
Okay. Let's wait for 2-3 minutes. Then I'll log the meeting. Please inform if please inform others in your personal group that class will start soon. My screen is visible to you all. Is my screen is visible to you all?
Ma'am.
Yes, ma'am.
Okay. Please let me know, okay, when the screen is not visible and all. Because sometimes it doesn't record the screen. If you don't let me know that screen is visible to you all, then I'll go on, you won't understand anything. So please let me know whenever the screen doesn't appear. 21 student. Okay, shall I start? 23 came. Please let me know when shall I start or not. Only 24 participants students came. What others? So have you gone through the topics I have discussed last class? Any confusion from the last class? Hello. Please respond so that I know that you are present and you are listening my voice. Hello.
Hello.
Hello. Am I audible?
Yes, ma'am.
Okay. So you have gone through the last class I have discussed, or some I have shared some words, some topics, not topics exactly, some words I have given just like three body diagram, stress, strain, and all. 25 student came. Let's wait for 2-3 minutes more. Do one thing, all of you write your roll number in the chat box till then. I'll note down the roll number. I'll take the attendance. Write your roll numbers in the chat box. Yeah, please mention in the group that I'll log the meeting. Then they won't be able to come to the meeting, and they will be marked as absent. Please text in your personal groups that I'll log the meeting soon. So those who are yet to join, they can join. After locking the meeting, they will be in waiting room. They can't join, and they will be marked as absent. So please text in the WhatsApp group that I'll log the meeting soon. 28 participants. Okay, I'm locking the room. Shall I log or wait for 2 minutes more? Please respond. Shall I wait for 2 minutes more or log the room and start the class? Anyone is there? Hello? 28, 29. Those who are new, please write your roll number in the chat box. Okay, I'll start the class. I'll log the meeting. It's 24. Okay. Hello. Good morning, everyone. By
Good
mistake,
morning, ma'am.
what? Someone. Wait. Ma'am, by mistake, I have write other roll number. So my roll number is 25. By, ma'am, by mistake, I have write other roll number. Why you have written others roll number? Yes.
해열 실험 그 홍보 있어요. 회사 나이다.
Okay. Please keep quiet. I'll start the class.
회사 또 나.
Who is speaking? Please, Majat, mute yourself. Okay. Good morning, everyone. So hope you have gone through the last class, what we have studied. So today we'll study. Today we'll mainly focus on the topics we have discussed in earlier class. Like I have explained, you have to go through these words. Normal stress. What is? We'll discuss normal stress. What is shear stress? Okay. Now, last class we have studied about axial centric loading. So axial load is loading parallel to longitudinal axis of the member. So when we are taking this member, the load perpendicular. Majat, please mute yourself. Just creating. I'm distracting. Majat, J. Kamiri, Samay. Mute yourself. Okay. Majat, mute yourself, please. Okay. So the axial loading means when the load is applied perpendicular to this surface, then the load will be your axial loading. My screen is visible to you all. Someone please respond. Are Are you seeing? Are you able to see my cursor and screen?
Yes, ma'am.
Yes, ma'am.
Okay, okay, okay. So the axial loading is when the load is applied to the perpendicular to this surface. This load will be centric when this load will pass through the centroid of this cross section. Okay, we have taken a truss. We have taken this truss and we have taken up the member HG. Okay, let me take out this person, Majad J. Khan. What is he doing? Let me take him out. Wait, wait. Not a minute. Okay. Okay, so you understand the axial loading? Axial loading means loading parallel to longitudinal axis of the member. So whatever be the member, when we apply the load perpendicular to the surface, that will be your axial loading. Okay, and the loading will be centroid when that load will apply through the center of the centroid of the section. So what is the centroid? Hope you are aware of this word. What is centroid? Suppose you have to find the centroid of this triangle. So what will be the centroid? What will be the centroid? Anyone? Hello? This is the introduction class. Please respond. What will be the centroid of this triangle? How will you find the centroid?
Ma'am, 2/3 of the height.
Yes, yes, you're correct. So so basically centroid is the point where the whole area is distributed at that point. Okay. So suppose this triangle will have its own centroid. This cross section will have its own centroid. Likewise, every section will have their own centroid. Okay. So in the same way, so in this section, we are applying centric load through the centroid of this section. So hope this axial centric loading word is clear to you all. Today we'll discuss, okay, today we'll discuss basically normal stress and shear stress. Suppose I have taken out this member. I have taken out this member. So I have applied external load, which is our axial centric load. Okay. Now I want to focus on the internal forces. As explained earlier, I'll take a structure, I'll apply external load, and then I'll see what are the internal forces generated. Hope I'm clear. Hope I'm clear from the last class. Remember? Yes or no? Hello?
ma'am.
Yeah. So I have applied the external force, then I have taken then I want to look into the internal forces in this section. So once I made a transverse cut. Forget about this, just focus on this transverse cut. I made a transverse cut. So this is the cross section, transfer cut. This is the force, exocentric load force. And if I assume what are the forces are acting on these two forces, one will be normal forces. If we found out the equilibrium of this section, then there will be one normal forces and there will be one shear forces. And when we go with the equilibrium, when we see the equilibrium, this P is equals to, let me change the color. This P is equals to this N, right? But for equilibrium, for this V, there is no upward direction force here. So V will be your completely 0. In this transfer cut, P will be equals to directly N. Clear? In this transfer cuts, if we see the equilibrium forces, so N is directly equals to directly P. But for the V, there is no other components to make it in equilibrium. So V will be equals to directly 0. Clear? Next, what we do a non-transverse cut. This is a transverse cut, we do a non-transverse cut. So we'll focus here. So if we do a transverse cut, this N will acting is in this direction. This is your N. And this this is your N, normal to the surface. N is normal force. So this will be normal to the force. V is shear force. So this is in this direction. So this normal force, this no wait a minute. This is your normal force. This will is your this is your V force. It is making a resultant. It is making a resultant which is P. Understood? Now this resultant P, if we make a equilibrium, this resultant P is equals to this P. Hope it is clear. Is it clear? Please respond yes or no. Whether then I'll know na that
Yes, ma'am.
okay, okay. What about others? You can unmute yourself and you can say. Hope you have understood. If you have any query, yes, yes. Someone said something. Yes, please respond.
Ma'am, can you please explain again?
Yes, yes, yes. I can. That's why I'm asking you to respond. So, from where I shall start? Shall I start with the next last slide? From here? Shall I start with here? Hello.
Ma'am,
Yes, ma'am.
transverse cut.
Okay. Let me start with here. So this is your. I have earlier classes. What we have done, we have taken a truss, right? We have taken out the truss. Then we have found out the various forces acting on this surface. You must have gone through this in your engineering mechanics class. How to take out these forces? Okay, that I won't discuss now. If later I get chance, uh, I'll give you some videos on that. So we are taking a cross section from this truss member, suppose HG, and we are applying axial centric loading, which is our external force. Axial means the perpendicular to this direction, okay, and centric means from the centroid of the section. See here, this force is applied on the center. One more thing, centric doesn't mean always it will be from center, okay, it will be from the centroid. A cross section may not have its centroids on its center, okay, based on its shape different cross section will have their different centroids, okay. So we are applying a load from centric loading. Axial centric loading, axial means axially perpendicular to the surface, and centric means from the centroid. So we have applied the load. So this is our member. Now I'm interested in what are the internal forces will be generated on this cross section when we applied an external load. So one I did transverse cut. I have cut the section in transverse directions, means perpendicular to the surface. So this is my transverse. This is my transverse cut. So if I want to know what are the forces, there will be one normal forces and there will be one shear forces. Between this section and this section, there will be one shear forces, and this section and this section, there will be some normal forces. Now, if we want to do equilibrium, what is equilibrium? Again, this is one thing. What is equilibrium? In equilibrium, forces are used to equate. Now, this in this direction, P is acting, and in this direction, N is acting. So these two, see, the direction of force here is in this direction, and the direction of this force in this direction. So both these are equal. P equals to N. Now, if you see the perpendicular direction force, only this force is acting, right? There is no force in the upward direction. So, how will we equilibrate V? So, V will becomes directly here 0. So, in transverse cut, our axial loading is directly equal to the normal stress of this section. Clear? Next, we want to see we want to see the internal forces when we do a cut in non-transverse, when we do a non-transverse cut. So this is the non-transverse cut. When we cut, there is a shear in this direction, which is V, and there is a normal stress or force, you can say, in this direction, which is N. Okay, so you have stress in this direction. Now you will need a stress in this direction, right? Another to equilibrium, but we don't have this. For to equilibrium, to make equilibrium for this, we have shear in this direction, but we don't have again the parallel direction na. So we'll take out a resultant, you know na, used to find in this na, there will be a p sine theta, then p cos theta, used to find the resultant of that r. Remember anything? There will be p sine theta. I'm doing with my mouse, it's not going. Suppose p cos theta, used to find a resultant, right? So here this resultant is your p, and if we do a equilibrium, this p will be equals to this p. Hope it's clear now. Shall I move to next slide? Shall I move to next slide?
Yes, ma'am.
Okay, okay. So let's look into the non-transverse cut. Are you able to see my screen?
Yes, ma'am.
Okay. Okay, let's look into the non-transverse cut more closely. So this is our non-transverse cut. The normal stress. What will be the normal stress? We generally represent normal stress by sigma, and this is the graphics of that. Normal stress means this is, we have made a transverse cut, or you can take this as a inclined plane. What are the forces will act in the inclined plane? So this is your normal stress. Parallel force per unit area perpendicular to the cut surface. Now our cut surface is in this direction and the force is in this direction. So both are perpendicular to each other. So basically this stress, force per unit area perpendicular to the cut surface. So force in this direction divided by the total area of the section. See, so normal stress is normal force per unit area, and we are assuming that the force is uniformly distributed over this cross section. Okay, so basically normal stress is what? Force per unit area perpendicular to the cut surface. So whenever a surface is cut perpendicularly, whenever a force is acting perpendicular to a cut surface, or you can say inclined surface, so your stress will be normal stress. And how to, what is the formula for normal stress? Normal force divided by per unit area. And the sign convention, if the forces are tension, if the forces are in tension direction, tension, if the forces are in tension, the sign convention will be positive. And the forces are in compression, see, I can take as compression is, this is the direction normally, this is generally represents compression, and this is represent tension, it is pulling out. So whenever the forces are in tension direction, the sign convention will use as positive. Whenever the forces are in compression, this direction, compressing, so it will be negative stress. Clear? Clear? Compression and tension. In trust, whenever when you have found out the free body diagram, compression, then forces in different members, then you must have gone through the compression tension. So hope it's clear now. Any confusion from this slide, or shall I move? 32 participants joined, but no one is saying anything. What happened? Hello?
Yes, ma'am.
Okay. Only one girl. Okay. So I'll move to the next slide. So we have discussed the normal stress. Let's move to shear stress. So shear stress is represented by tau. Again, this is the shear stress. Now, if we zoom out the section, this is the shear stress. So force per unit area parallel to the cut surface. When the force is applied parallel to the, this is the cut surface. The force is in the direction of the cut surface. That will be that that force divided by the cross section of the area is represented as shear stress, tau. So tau is basically force per unit area parallel to the cut surface. Shear stress divided by area, cross section of that area will give you shear stress. And here also we are assuming that the shear stress is uniformly distributed on this cross section. Or you can say not of this non-transverse cut you can take as stress on an inclined plane or inclined section also. Because see the cut section is in it looks like it's an inclined plane. This these two words will help you later on. So first you have to understand what is normal stress, what is shear stress. Clear? I'll try to find out any video on this. I'll share. So note down this question as a homework. Okay. I'll discuss the solution in the next class very briefly, but I want you all to do this one by yourself first. Then we'll match with the answers. I'll match with everyone's answers. Then I'll discuss what are the problem they have faced. Then we'll discuss the solution how to do. So basically, it's a flat steel alloy bar has a thickness of 10 mm and a width of 60 mm. It is subject. My screen is visible to you. The worksheet. Hello.
Yes, ma'am.
Okay. 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 A flat steel alloy bar has a thickness of 10 mm and a width of 60 mm. Dimension of the steel alloy bar is given to you. Thickness is 10 mm, width is 60 mm. It is subjected to an axle-centric load in tension of 60 kilonewton. That means your P is your 60 kilonewton. Determine the normal stress and the shear stress in the bar on both the transverse plane and the inclined plane. So you have to find out the normal stress in the transverse plane and also an inclined plane. And the ratio of this inclined plane is 4:3. So please do this worksheet. No issue if you didn't able to solve, but try. See, I want to see who has tried. So that I can note down who is doing the class very sincerely. Okay. Use your concept, use your thing, whatever you have understood in these two classes, or basically this will based on today's class. This is shear stress. This is normal stress. This is the force. Take out the transverse cut from the sections. It will make it take out the equilibrium. P will be equal to N. So it will be easy, I guess. P will be directly to N, the normal stress. Then for the shear stress, you have to find the N and B from the resultant. Clear? Understood or not?
Yes, ma'am.
Okay. So 32. Those who were absent, please write your roll number in the chat box so that I can mark the attendance.
Ma'am,
Yes. Yes.
ma'am, should we prefer any book for this subject?
Sorry.
Should we prefer any book?
Book means see your course is combination of two subjects. So which book I'll suggest I don't know. And someone asked me the syllabus. I'll surely share the syllabus to you all. I was busy in uploading all this. I'll surely share the syllabus. So you have to go through by topics. I can prefer you a single book because you won't get topics in a single book. Then also I can suggest you theory of structures. You can go by Ramamutham. PDF is available or not, I don't know. I have to check. But I'll say don't go by book. Go by videos. You'll get lot of explaining videos on these topics. You'll understand. Then also you want to go through books. Just give me some time. I'll list out some books and will advise you. Is it okay?
Okay, ma'am. Okay, ma'am.
Okay. Any more questions? And please, those who were new, I have not marked your attendance. So please write your attendance in the chat box so that I can mark you present. I've marked only 23 students, I guess. 23. Any questions from the last class? Those who were not present. Have you noted down the questions? Am I audible? Have you noted down the question?
Yes, ma'am.
Yes,
Yes, ma'am.
ma'am.
Do one thing. We have time. We have time. Try try the numerical now. We have time, so you can do the numerical. You can try the numerical now. If time permits, I'll share the solution also. Try it once. All of you try in your copy right now. We have time. If time permits, I'll discuss the solution also. It will be better. Everyone try. It's 11:48 at 12. Sorry, not 12. At 12:05. Let me know the answers. Just try once. Till then, I'm marking the attendance. Everyone try. Just give it an attempt. Anyone found out the first question, first answer? Anyone got any answer? Please let me know when you find out any answers. It's very easy. If you just use the equilibrium concept, it will be very easy for you. Anyone there? Got answers? Hello? Anyone is there? 30 participants. How become it 30 participants? 31 are there. Any answer? Anything you got? Please respond. Got the answer or not? Don't worry, it can be wrong. No issue. Okay. Shall I show you my answer? Please respond. Okay.
Ma'am,
Yes, yes.
this normal stress is it 100 Newton per mm square?
Normal stress 100 for the transverse plane or inclined plane.
Transverse, transverse.
Transverse plane normal stress is not 100. Not 100. What you said 100?
100 Newton per mm square.
Yes, 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 yes. Yes, it's 100 Newton per mm square. Good. And shear stress?
I have not found it. Trying,
Okay.
ma'am.
Okay, okay. Please try. Good, good, good. Good going. Good going. Try. It's easy. Very easy. The first one. Still, I want you all to try. And For this subject, you should know the conversion, okay? Kilonewton to Newton, then you should know the how to convert in mm per square. My question screen is visible to you all? Hello? Okay, okay. Anyone? Okay, students, the meeting will end in 5 minutes. So let's discuss the solution. Shall I show you the solution? Hello?
Ma'am.
Okay. So you're seeing my screen? My screen is visible to you all? So basically this is the solution. So for the transfers, sorry for the inconvenience. Screen is not getting. Wait, let me try. Now it is visible. Hello? Hello?
Ma'am.
Okay.
Yes,
So
ma'am.
for the transverse curve, I am representing it as 80. Okay, and on non-transverse curve, I am representing it as A. So sorry. So for the transverse curve, if we do a transverse cut, what were the force? P and N and V. So for the equilibrium, P will be equals to N, V will be 0 or not, right? Yes or no to bolo. Please say yes or no.
Ma'am.
Okay. So this V will be equals to 0, P will be equals to N. So we got N 60 kilonewton, and we know normal stress is equals to N by A. So our A will be your 600. How? Width into thickness. of the section will give you area. So force by area will give you sigma or normal stress 0.1 kilonewton per mm square. As this is a positive sign, so it will be tension. If you convert in MPa, this will be your 100 MPa. So this is the conversion 1 kilonewton per mm square equals to 100 megapascal. Now shear stress. When shear stress V equals to 0, when the shear force is 0, so what will be the stress? Obviously it will be 0. Yes or no?
Ma'am.
Got it? This part is clear?
Yes, ma'am.
Okay. Okay. Now for the transverse plane, this is the free body diagram. Here P is acting and V will be in this direction. We have to find this P will be 60. So for parallel and perpendicular components, okay, you have to go through the engineering mechanics. Okay, today let's stop with here. This part we'll discuss in the next class. Okay, you take out the photo of this one and try to understand this whole thing. We'll discuss this part in the next class. What do you say? Is it okay?
Okay, ma'am.
Yes, ma'am.
Okay. I'm ending this meeting. So those who have left to give the attendance, please give your attendance, huh? Those who are left to give their attendance, don't leave the meeting until I get the attendance. Otherwise, it will be difficult for you, for me also, to put it again.